This is the first video of the next unit, the next second unit out of our 4 units that we do in the course. This unit starts out with chemical equations, balancing chemical equations, and then using balanced chemical equations to solve chemistry problems caused stoichiometry problems. So let's dive in. Okay, first thing is we have a chemical reaction. You've seen them before. You know what they look like. Let's just go through some terminology. All right, now over here on the left side of this arrow, arrow, the left side of the arrow, we have some, well, here is hydrogen and oxygen, but we have what are called the reactants. The things are going to react together to create something which is then called the product. So on the left, we got our reactants. On the right, we have our products. Okay, very simple. This just is an arrow. For now, we're going to keep our arrows going in one direction. If you ever have to take chemistry 2, you will learn that these arrows can go in actually in both directions, and that causes some sweet chemistry to be done. But I'm just going to put the arrows to the right for now, and we're good with that. All right, diving in then, what do we got? We have, if you look, what's called an unbalanced reaction. Just one other thing. Sometimes you will see in a chemical reaction little symbols like that. G for gas, hydrogen and oxygen at room temperature are gases, and they can form water, which is a liquid. So you'll see that. Sometimes you'll see AQ like that. That means aqueous. That means that thing is dissolved in water, floating around in water. So down here we have maybe some calcium and calcium nitrate, which is very soluble, dissolves in water easily. So if this was in water, this would be aqueous. You also have solids. Sometimes these aren't in water and you have solids. So we might have aluminum solid, and you'll see those symbols. So, and you've seen them before, G for gas, L for liquid, and S for solid. That makes some sense, doesn't it? And AQ for meaning it's floating around in water. It's dissolved. Okay, moving on. So what you have to do, though, is you have to have what's called a balanced reaction. You remember earlier in the course, in one of the videos, we went over the law of conservation of mass, or the law of conservation of matter. That means you cannot create or destroy matter or mass in an ordinary chemical reaction. And we're doing chemical reactions. It's chemistry. So we have a chemical reaction here, 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 and here. I've drawn 4 of them out. By the way, I just took this one. I did not. I just made that one up. But these 3 are off of this worksheet, which is loaded into Essential Documents. Okay, it's balancing. It's under B for balancing, so it's relatively high up in the chart of Essential Documents. And you have some reactions to balance. And I just took a bunch of them from here. This is really good practice. I would recommend that you get this, you practice on them, and I will put the answers in by the end of the week. So you can look and see how you did for your practice. Because your book, I did assign some problems with balancing, but there aren't that many of them for practice. That's a lot of practice, so that's what we got going on there. So now let's see. Let's go ahead and balance this, because this is not balanced. What does that mean? What are you talking about? On the left, I have 2 hydrogens and 2 oxygens. Remember, those are the diatomics. Remember 777? Yeah, those are diatomic. When they're by themselves, always. And you got to know that. You got to know that. You got to know that. So we have 2 hydrogens, 2 oxygens. If I look over here on the right, the water is H2O. 2 hydrogens and 1 oxygen. That's not balanced. We can't just have an oxygen disappear. That doesn't happen. So we have to make sure that what we have on the left equals the stuff on the right. We have to balance these reactions, making sure I have equal amounts of reactant and product, so we're not violating the old law of conservation of mass. All right? No law violators, please. All right, so what do we do? There are what I call guidelines. Again, no rules. You people are angsty and don't like rules. So I will give you some guidelines as to how to solve and balance a chemical reaction, how to solve the problem for getting it balanced. I'll put these guidelines over here. All right, I think we can read those. Yeah, okay. Guideline number 1. Again, you don't have to do it in this order. I do it in this order because I know it's the easiest way of doing it. But you don't have to. You can be a rebel and actually go in reverse order if you want. As long as you have equal amounts of stuff in both sides, doesn't matter how you got there. But there is an easier way, and here's what I think it is. Balance metal. So balance metals. So the first thing you want to do is you want to balance your metals. And you know where the metals are on the left side of the step-like line. Most things in the periodic table are metals. You're going to want to balance those first. Second thing you're going to want to do is then balance polys. Now, what I mean by polys is polyatomic ion groups. If you see a polyatomic ion group, and at this point, I hope you identify at least those 10. You just have to know them if you want to do chemistry well. Speak the language. So those 10 you should know, but there are other ones. But you can identify polyatomic ion groups. Usually going to have brackets around them. And so at this point, you should be able to identify a polyatomic ion group. And you balance those next, and you balance the group next. And then, of course, we're going to demonstrate this in just a second. Third, I'm not going to write balance anymore because you get that part, right? So third, balance single nonmetals. Single nonmetals. Single non-metals. Balance single nonmetal. Well, again, we're going to explain this in just a second. But I mean, a single nonmetal here would be chlorine. Okay, what I mean by single, not that there's only one of them, it's just that chlorine is not wrapped up into a polyatomic ion group. Like this nitrate here, the polyatomic ion group has two nonmetals, but they're together as a polyatomic. So that would not be what I would call a single nonmetal. That's a polyatomic ion combination. What this chlorine is, because it's it's hanging out there by itself, not in a polyatomic ion. All right, fourth, and here we go. This is really what you're trying to do. Fourth, balance hydrogen. And then fifth, oxygen. Hi-ho. What you really, the bottom line on this is you really don't balance oxygen until the end. So don't start out by balancing oxygen, because I call that chasing your tail. What you'll end up doing is you'll balance one side and you'll go to the other side and balance that if you start with the oxygen, and then you unbalance other things, which unbalances your oxygen, and you start going, okay? So that's really what you're trying to do. You're trying to just don't balance the oxygen until you get to it down the line of balancing everything else. And then probably 99 times out of 100, if you do these steps first, the oxygen is balanced at the end, and you don't have to worry about it. It's going to be all balanced for you anyways. So that usually is what happens. Again, you don't want to do it in reverse. Some of you might go, I'm doing it. Oh, you can't tell me what to do. I'm going to start out with balancing the oxygen. Okay, all right. I mean, whatever works for you. I mean, it does work sometimes, but not all the time. And I don't want to hear it. You didn't hear it from me. Okay, you heard it from, don't do that. Okay. So this is my general way of balancing, and I think it works best. I think it comes out to be the easiest. A lot of times by the time you get down here, the hydrogen and oxygen, they're already balanced for you. Okay, let's go ahead. Let's dive in. Let's balance these. 2 hydrogen, 2 oxygen, 2 hydrogen, 1 oxygen. You cannot ever mess or scutch. I like that word scutch. Do not scutch with the subscripts. In other words, you cannot balance the oxygen by putting a 2 here. Come on, you know that, right? I mean, that wouldn't be water anymore. Now it's hydrogen peroxide. And it wasn't hydrogen, it was water. So we can't change the compound, because that's what you're going to do if you mess around with the subscripts. So don't touch those. You have to put what are called coefficients. So our subscripts, those are the numbers that we have, of course, just behind in lower, sub, below each element. You're going to put the coefficients. Those are the numbers out in front. That's what you need to do. You need to put numbers out in front to do your balancing. So if I have 2 hydrogens and 2 hydrogens, or actually if we look at the rules, we actually, because it's water, it only has hydrogen and oxygen, we go immediately down to number 4, balance the hydrogen. Balance, okay, now I've got to balance the oxygen. And this is one case where it's not balanced when I get down to that, because all I have is hydrogen and oxygen. So oxygen not balanced, so can't put a 2 here, you've got to put a 2 here. That is a multiplier. That coefficient multiplies everything that it precedes. So there, in other words, I now have 4 hydrogens. What? That's a problem. Well, it's a temporary one, easy to fix. And 2 oxygens. I have my oxygen balanced. 2 oxygens, 2 oxygens. Nice. Balanced. Well, now, sometimes when you balance something, you unbalance something else. So you have to go back and rebalance it. And that's what happened here, because I had 2 hydrogens, that was balanced, but now I put a 2 here to balance the oxygen, I unbalanced the hydrogen. So 4, 2, we put a 2 in front of that hydrogen, and we're all balanced, we're good to go. All right, let's keep going. Let's try this one. Again, I got these off of the balancing practice sheet. Lots of them on there for practice. So 1 zinc, okay, what I'm gonna do first, balance the metals first. And zinc's a metal, so balance that first. One zinc, one zinc. Balance, move on. Step 2, balance polyatomics, don't have any. Balance single nonmetals. Well, I suppose you could call this a nonmetal and it's by itself, so I guess in a way that qualifies as a single nonmetal. Balanced hydrogen, don't have it. Balanced oxygen. So for either reason, 3 or 5, we're balancing the oxygen now. All right, 2, 1. Same thing as above. I'm going to have to put a 2 in front to balance out my oxygen. All right, now that unbalances the zinc, go back and fix it. So zinc 2, put a 2, balance. All right, let's try this one. All right, metals first. Aluminum, 1. Aluminum, 1. Nice. Polyatomic ions, don't have any. If you know your polyatomics, then you know that you don't have any. Okay, so move on. Single nonmetals. Okay, that this chlorine here is a nonmetal, and it's not wrapped up in a polyatomic, so that's what I mean by single nonmetals. Balance that next. So here I have 1 chlorine, 3 chlorines. Put a 3 in front as that coefficient to balance that chlorine. Okay, next, go to the hydrogen and balance the hydrogen. All right, is it balanced? Is the hydrogen balanced? The answer is 3, 2, no. It's not balanced. Crap on a cracker. How are we going to balance that hydrogen? 3 hydrogens, 2 hydrogens. Okay, this is what I call when you have 3, an odd number, and 2, an even number on either side. This is what I call the common multiple solution. What you do by 2 and 3 or 3 and 4 is you multiply the 2 numbers together, the 2 and the 3, and you get 6. So what you're going to want to do is try to get 6. Take these 2 numbers, the odd and the even number on each side, and multiply them together, and that's what you need to shoot for. Try to get 6 on each side. How would I do that? How would I do that? Let's see. How would I get 6 on this side? How would I get 6? Because with 2 and the 3, those hydrogens, we need to multiply that number and that number together and get 6. So how do I get 6? Put a 3 here. 6. Okay. What about here? What am I going to do? Change this to a 6. So you had a 3, make it a 6. And now what do you have? You have 6 hydrogens. So 6 hydrogens, 6 hydrogens, balanced. All right, now, I don't have any oxygen. I don't have to worry about that. But what I do have to do is check to see by changing one of the subscripts, which we had to do here to get the hydrogen balance, did you unbalance something else? And if you did, you got to fix it. All right, and we did, because now look, now that gives me 6 chlorines and only 2 chlorines. 3 chlorines, so I'm going to have to multiply by 2, put a coefficient here of 2, and that gives me my 6 chlorines. So those 6 chlorines are now balanced, and that also unbalances the aluminum. So now I have 2 aluminums here, you need to put a 2 here in front of that aluminum. These are like little puzzles. I mean, some of you like crossword puzzles, right? You like, the word search or whatever puzzles you like. This is like a little puzzle. It's fun, yeah, fun, yeah. All right. Now, actually, we went from out on the stove into the frying pan on this one. This one was super easy, and all of a sudden, this one was like boom, 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 boom. Now, okay, we had a lot of things going on in that one. We got to go through 1, 2, 3, and then go through and rebalance. So, that was a big jump. Were you okay with that? If not, go back, rewind, lather, rinse, and repeat, as I always say when you wash your hair. Okay, you go through follow the directions until you're out of shampoo, because if you lather, rinse, and repeat, you got to do it until you're out of shampoo, right? Yeah. So go back and watch that again. All right, let's try this one. Metals first. Calcium, calcium. Balanced. You only have 1 of each. Lead. Lead's a metal. So lead, 1, lead, 1. So far, so good. Maybe it's all balanced. Maybe this one's just already done for me. Balanced polyatomic ion groups. Nitrate, nitrate. Oh, wait, you know what? I think I copied this one down wrong. Hang on. Did I copy this one? Because that ain't right. Because it is balanced the way it says now. So, all right. Let's see. Which one was I doing on the sheet? Just bear with me. Bear with me. Stop trolling. I'm trying to find another sheet. Oh, I was doing number 6 on side 2. Number 6 on side 2. And you know what? I did copy it down right. It is balanced. All right. Okay. That one's already balanced for you. Easy peasy. I didn't, when I was writing it down, not paying attention, I just wrote it down. That one, too easy. T-E. No, we're not getting off the hook. No. We're doing another one, okay? Find another one on here. That is not balanced. Let's see. Aluminum. Yeah, that's kind of easy. Okay, number 8. I'll just go down to number 8. I was at 6 on that one on the second page. Now I'm going to go to 8. So zinc plus tin nitrate. Okay, zinc plus tin nitrate. I'm going to make zinc nitrate and tin. So we get some zinc nitrate and tin. All right. And we've copied it down right. Yeah, makes sense. It's actually what's called a single displacement reaction there. And let's go ahead and balance it. Zinc is balanced. Tin is balanced. So far, it's easy. I mean, it's very much like the one I was just doing, but like I thought it was going to turn out was the nitrate's not balanced. And this one's not. So 4 nitrates, 2 nitrates, what do you do? 2 nitrates and 4 nitrates. Multiply this one by 2. That gives you 2 times 2 is 4 nitrates. That's balanced. But what did we do though when we did that? We unbalanced the zinc. So 2 zincs, because remember that coefficient functions as a multiplier for everything in that compound, everything that it proceeds in that compound. So that compound gets multiplied by 2. So that's 2 zincs, so I need 2 zincs. All right? So that one was the way I thought the last one was going to be. Not paying attention when I wrote that last one down. Okay. Once in a while you get some fun stuff. So most of your balancing reactions aren't that difficult. I mean, they're basically the same level that we just did. If you can do that third one down, where you had to kind of go back a couple of times, you had to use that, the 2 and the 3, the common multiple that they both have. That one is probably the most difficult one you'll get. They're typically not hard. But once in a while, you get a fun one like this. Okay. Let's say that I have that compound, C2H6. And it's combusting, and it's forming some carbon dioxide. Need a little room here. Carbon dioxide and water. It's what's called a classical combustion reaction. So we're combusting this, and we look at it, and we say, okay, this is the typical form for a combustion reaction. We'll go through this in a little bit more detail in a few weeks, so you'll be able to pick this up pretty quick, but you don't need to know what kind of reaction it is. But let's go ahead and balance it. 2 carbons, 1 carbon. You need a 2 in front of that carbon. Oh, wait, let's go through the rules. I'm sorry. I want to balance metals. I don't have any. Okay, balanced polyatomic ions. I don't have any. Single non-metals. Well, carbon's a non-metal, and it's not in a polyatomic, so I'm going to go ahead and balance that first. Remember, I'm saving my hydrogen and oxygen to the end. That's really what you're doing. Save those to the end, balance everything else. Okay, carbon, 2 and 2, got that. Next, I'm going to go for the hydrogen. 6 hydrogens, 2 hydrogens. Put a 3 coefficient in front. Now it's balanced, the hydrogen. All right, fingers crossed. Maybe the oxygen will be all balanced for us, and we'll be done. 2. Now carefully, because the oxygens are split. They're split in the carbon dioxide, and they're split into the water. So we have to add up the total amount of oxygen on each side. So there's 2 here. Here there are 2 times 2 is 4, plus 3 times 1 is 3. So on the right, I have 7. 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7. Okay. Now, in a case like this, I'm going to ask you a question. I could balance this. I'm going to need a little room here. I'm going to put my positive a little bit more to the left. Need some room. I could balance it this way. Okay, watch this. I could balance it like this. 2 times what will give me 7? Go on, you know the answer to that. 2 times 3.5 gives me 7, right? It does. So if I put 3.5 like that, it's balanced. It is. Come on, don't deny it. You know that's a balanced reaction. You know it is. There's equal amounts. 3.5 times 2 is 7 oxygens. We still have our 2 carbons and our 6 hydrogens. 7 oxygens on the right. It's balanced. But you also know there's a problem with that, don't you? Yeah, see, you're smart people. You also know you can't have a fraction as a coefficient. You have whole numbers, and only whole numbers. You can't have half of an oxygen molecule. You either have one or you don't. So we got to get rid of that half. How do we do that? Well, the important thing is we keep a whole number ratio when balancing. Remember that kind of showed up earlier, multiple proportions, whole number ratios. Whole number ratios with empirical formulas, blah, blah, blah. If I double this, multiply this by 2, and multiply everything else by 2 to keep the same ratio, then I will have a balanced chemical reaction that doesn't have any fractions in it, and I have the same ratio. Yes, this is a balanced reaction as written. However, you know you can't have a half, so you've got to get rid of it. How is the easiest way to get rid of a half? Multiply it by 2. Okay, what does that do? That gives me 7 oxygens. 2 times 1 gives me 2 of the ethane, plus 2 times 2 is 4 carbon dioxide, plus 2 times 3 is 6 waters. If you look at that now, the ratio is the same. Same ratio here. And I know I have a balanced chemical reaction without any halves in it, and that's how you should properly express it. So, once in a while, you get one like that. Okay, all right, yeah. And that's balanced. And you might say, oh, you'll never give us something like that on a test, right? You would never do that to us. Of course I would. I wouldn't spend the time going through it if I wasn't going to give you one like that. I will give you a hydrocarbon one that has a half and a doubling going on to balance it. So yes, I will. Okay, this video has been over 22 minutes long, so I don't like long videos like this. So I'm going to stop it here, and we'll pick it up in the next video with what are called mole ratios.